clearly see both, say, in C++ and C#, which are both languages that have followed that trend of ever more complex. There have been, let's say, tools, frameworks that can be used to deal with the front-end parts of any analysis tool. If you have to process C# in any serious way, you can use Microsoft Roslyn and have a complete object model that represents your program at all abstraction levels and do virtually everything you want to do about it. In other words, the availability of Roslyn in that area has been a game changer. I really think so. It has also enabled tons of other things more on a more industrial side. But if you are to analyze a few gazillion lines of C# code, well, you're not starting from scratch. You can use Roslyn, and it does an absolutely magnificent job at performing the analysis up to the level you want it to have. It's up to you to say, I want it to be, syntactical, semantic, type system, whatever you want to have. And I've never seen them firsthand, but I've heard of similar efforts using the Clang front end for C++. This being said, I don't know whether there's something similar or whether there should be something similar for Java. At some point, there was a technology called Jackpot, which was exactly this. It was a class library that allowed you to manipulate Java systems. I thought it was magnificent. I read a few papers, I saw a few demos. I thought, okay, this is going to be a game changer. Well, so much for my insight. I think that Jackpot has pretty much disappeared.
Even if you have a good library that can give you APIs, you still have to deal with all the complexity of the language. Yeah. I mean, they can reduce it some, but it feels like
it's going to depend on the level of granularity, on how deep you want to go. And then talking about macros and preprocessing, one of the big problems in analysis, both from academia but also industrially, to analyze systems written in a language with preprocessing, is that for all practical purposes, you can't analyze the artifact that the user is actually running with. You can analyze an intermediate artifact and hope that whatever conclusion you come up with are relevant enough for whoever is working with it. It's not a given. It's a gamble.
Of course, I work with languages that have eval, where you can load new code dynamically. So that's a whole different level of fun, because you can't analyze code you don't see, or it's harder. You can guess, but yeah. So that's another challenge. There's a spectrum of languages, right? You can imagine all the way to one side there is theorem proving, where you sort of have programs that are proofs, and on the other side of the world you have languages like JavaScript and Python and Ruby, where everything is dynamic and you can redefine everything. And then in the middle there's a range of type systems that go from fairly simple to all the way to very, very strict. And your languages, you could imagine they are on that spectrum. Where would you like to live? Are you a lefty or right-winger?
Yeah, okay, let's say political metaphors aside, I don't want to decide whether this makes me a lefty or righty. I am more of a strong typing kind of guy. There's no question about it. And again, this really comes from my father. He's the one who told me in due time, C, we should try the C programming language, and said, no, I'm going to stick with Pascal. We know that Pascal doesn't have such a great and such a strong type system, but it was obviously more robust than C, and definitely C as was used in the time. And that stuck with me. And remember, I'm paranoid, so I use all the help I can get. And a strong type system is part of that help to me. I have never used calc and the theorem proving kind of things. It scares me off. Uh, some of the people I talked to who've used it said, well, it does work, but it's a dark art. You end up not just writing code that is correct. You have to write code that's going to be swallowed successfully by Coq, and that's not a given. So there may be a need for more work in the state of the art there. So no, I'm definitely more of a typing of a strong typing kind of guy. At the same time, I remember. I'm sorry. I'm going to talk about many other people because my opinions are not all mine. They come from people I talk to in due time and respect. Um, the guy is Claude Cherton, and whoever has known him remembers him vividly. He was teaching in Namur for 30 years, and an absolutely wonderful guy. And he told me something. He says, it doesn't matter how much control you put in your language, it does not alleviate the developer's responsibility. At the end of the day, it's the developer's responsibility to make sure things are correct. And strong typing can help you, but you will never be 100% safe. It's always going to be part of your personal responsibility. And that's really where I stand. At the other end of the spectrum, I once attended a conference on the Z notation. I don't know if you're familiar with that. I dealt with those things. It was fun. And there was a guy who, it was not Abriel himself. Abriel is the guy who wrote that big thing called the B book, right? And B was supposed to be the way to write software. I think they claimed, right or wrong, that it had been used for the subway systems or was it Esterel? I don't know. But B was presented as being the thing, the way we would do absolutely perfect by design software. And the B book is like a big, big fat book. And I'm not entirely sure about the metrics, so don't sue me and don't quote me on this. But I think there's a section on like 100 pages easy, that shows how you can write a guaranteed correct binary search in a table. It's super impressive, and it actually demonstrates how this cannot be used at scale. It's just mind-boggling. And at that conference, I remember people telling, Word, MS Word, that they all use as the yardstick for this kind of thing. MS Word should be written using this method. I say, you guys, you're out of your mind. I had to walk out of the room because I was laughing so hard. I mean, if you look at the complexity of MS Word and all the things it does, designing it with something that is so verbose is mission impossible. Which, by the way, brings me to something else, which is so unpopular, but I think it's really true. It's depending on the application, we are okay with more or less perfect software. We are demanding perfection in all areas is unreasonable, and we accept Word works as it does. If Word crashes and you lose a document, it's annoying. Under normal circumstances, nobody dies, and I guess that's a reasonable trade-off, and we are ready to accept that.
It's sort of risk management, right? You're saying, what is the worst case that can happen if this thing blows up, and can I live with it? And if you can, then okay. I mean, the price is not so high, and you're willing to tolerate the error. And I think this is this is in that whole space. People were thinking about. So there's beautiful work on verified compilation. And verified compilation is great, but it takes so much effort to verify, the algorithm, that you're not going to change it much. Now, you look at any real-world compiler, you look at, V8, they the Google JavaScript engine, they rewrite the whole thing every couple of years. So there is no hope, like the rate at which the algorithms change is so fast that, you can't, there's no way this could work. So the question is what is the price of failure? So if you're going to compile the code for the steering system of a plane, the price of failure may be high, and you may be willing to put up with the cost. If you're writing a game that runs in a browser, you don't give a fuck.
But you know what? Back the question to you. What do you think? Where are you on that spectrum?
I don't. It varies. So it varies because. So I write. Sometimes I do data analysis. Got gobs of data, and you want to have insights, and I use the R language for it. And R has these essentially higher order tables that you can manipulate incredibly fast, incredibly easy to write code. If you had to think of a type system, and I tried to, for this, it's just impossible. It would be so verbose, so complex, it's just never gonna happen. We tried to use APIs for doing the same thing in Rust. And the code was, 20 times longer, unreadable, and it just, made me want to puke rather than actually use the Rust version of this. Okay, performance, maybe there was a win, but the point of these kinds of tasks is you want to iterate quickly. You want to analyze code, you want to get insights, maybe this was not the right analysis, or you're going to move and try something else. So untype is right. For this, perfectly fine. I remember, back in the 90s talking to folks in the banks in Switzerland, saying, but you're using Smalltalk, you're a bank, there's got to be bugs. And said, yeah, there are bugs. And if you had a type systems, and they laugh and they say, the typing bugs, they're the easy ones to fix. It breaks, it stops here, you know why it stopped, you fix it, it's no big. They're the easy ones to fix. I remember there was another fellow who was working on the Swedish pension system, and they had done it in Perl.
Ouch.
This whole Sweden was, their pensions were computed by a massive Perl job. And, they said, well, yeah, types, yeah, but, really types wouldn't help much. We know it's a number. What we want to know is if it's the age of a person or if it's, something. So they said, well, we would need, the kinds of, or if it's, you would need more richer types than the languages, you're selling us would offer. Is this the right range for an age and things like that?
Essentially, they're making a case for Ada, I guess, type-wise.
Yeah, there's lots of type systems out there that can go further. But then you go to see other people's code and you try to read untyped code and you say, I have no clue what this thing is doing. Okay, there's comments, the comments are out of date. So then you start to think, there is a value to these type things. And so that's where I am. I'm in this space where I see that for certain tasks, types are going to slow you down and not necessarily, pay back as much as you would like. But, if you're writing a library that other people really use, yeah, you want types. You want types because they're your specification. So I've worked on this for a bit, but my dream is to be able to have both, right? To have types when you need them, and as rich as you need them, and to ignore them when they get in the way. So you can imagine saying the compiler, yeah, I know that this looks wrong, but just run it.
Yeah, in fact, what you want is perhaps is this something that you could do with TypeScript?
To some extent, so TypeScript gets you some of that. You can have code that is untyped, you can have code that is typed. One of the things that bugs me with types is they, generally speaking, they render your software much more rigid. So I remember, years ago, I was working with an implementation of Corba, which is a horrible thing, never do it. But they had written in an object-oriented styles, lots of interfaces, classes, and I wanted to do one thing that was really simple. I wanted to try to add one argument to a method. But in order to add that argument and call it in that one place, but in order to add that one argument, I had to extend the interface. In order to extend the interface, I had to extend all the subclasses and then fix all the call sites. And before you know it, it was 5 days of work for an experiment that didn't work. Whereas I would tell, please compiler, forget what you're thinking. Just run this code for me. Tell me what happens, not what you think will happen.
Yeah, I'm not sure that when it comes to methodology, I'm crazy about the idea. I hope I'm reasonably understanding for my colleagues, flaws and the hardship, and the work isn't always easy. But the part that makes me yell is when they push something that is an experiment like this, code that is obviously broken, say, yeah, but it's for now or for the time being. And it's just, I call it a booby trap, that you leave for your colleagues later. So that's in terms of methodology, the idea of saying, yeah, execute it and forget about everything, I think it's like, it makes me a tad nervous. But again, talking about segues, what's your take on JavaScript?
It's a surprisingly robust abomination. For what it is and how it was designed, it has managed to survive and then thrive and create an ecosystem that is rich, interesting. TypeScript is an interesting evolution in that space, right? It's trying to, I've been, using TypeScript for teaching, and it is actually fine, right? So it's a surprising beast. I would, not have picked JavaScript as my language of choice for anything, really. But by the time we get to TypeScript, it feels much more usable. So what I don't like, so I'm more gentle on JavaScript than on the JavaScript ecosystem, and in specifically the node npm, and that is where the true horror lies, right? When you load any, and this is not 100% a language issue, it's an ecosystem issue, but when you load, any npm program, you're typically ending up with megabytes, up to hundreds of megabytes of code for seemingly simple tasks, and you go like, how is that possible? I'm loading a calendar, and this is 50 megabytes of source code, and then you sort of realize that, well, there's this library, and it pulls in this library for doing formatting, and there's another library, it pulls another formatting library or another version, and before you know it, you have downloaded so much code. Now you think, what are the odds that all of this code is safe, all of this code is correct? Back to risk management. Maybe I don't care, but if I really didn't care, I wouldn't write software to do things, right? I mean, usually you want them to be done. So there is this, it is a very sort of undisciplined world that people live in that space. And I've also had experience just teaching with it, and there's so many version issues that the software seems very brittle. So all in all, I would say, don't try it at home, kids.
What amazes me with JavaScript, I agree with you. I mean, my take is marginally different, but all in all, I agree with you. What amazes me is that facing what I see as being dramatic flaws, there is an entire generation of people to whom it's no longer a question. Computing is JavaScript. And that's it. And that's the end of it. The idea that there's another language, oh no, that's for technical people, or that's for experts, whatever you want to name it, or that's for marginal thing. The entire world is JavaScript, which I think is mind-boggling, is absolutely mind-boggling. And at the same time, I can only observe, who am I to say? But in fact, sometimes I say that TypeScript is a testimony of two facts, two important facts. It's first a testimony that JavaScript is here to stay.
Yeah.
Otherwise, Anders Helsberg would have designed a brand new language from scratch. He's a genius. He could have done it easily in his sleep, drunk, blindfolded. No, easy. But he didn't. He designed this as an extension of JavaScript, which is a tribute to the long-lasting effect of JavaScript. And then the very existence of TypeScript is also a testimony to the dramatic flaw of JavaScript, namely that without types, it should not be put in, let's say, the hands of anybody. So it's yeah, but I really agree with you. It's JavaScript is something I can only observe and wonder, how did we get there? How did we get there?